Is it all visible?
Yes.
Great.
All right. So, good morning, everyone. My name is Krishna Kumar. I'm basically part of a company called Emergeway Academy. And I welcome you all for this webinar today. Basically, we did this on the 20th, and we're very, very pleased that we had so much of participation that we pushed ourselves to do a repeat of the same thing today. Thank you very much, Prasad, for honoring us and making sure this is happening. So I would first like to take you through what is Emergeway and who we are briefly, and I'll possibly then introduce you to Dr. Prasad, who's going to be our trainer today, and allow him to take us on through the presentation. Okay, so Emergeway Academy is a company founded by a group of experienced professionals. Okay, so this means like there are a lot of people that are part of Emergeway directly or indirectly in the capacity of an industry expert, in the capacity of someone who has a lot of domain knowledge on a certain area, and who brings a lot of experience from industry. You know, average experience from each of us is about 30-35 years. And our primary goal has been always to impact an individual's capacity, throughout his career as from the power of training. Basically, we are a training company. Simply said, we are a training company. And as part of our training, we work with multiple colleges. Some of you from some colleges here know us because we work with you guys. And many we are in talks with. We may not have started a program there, but yes, we have interacted with a lot of students, and we know that there is an interest, and we basically train college students. Our goal there is to give them industry readiness in terms of like all you guys students are basically receive a lot of education academics from the college over 4 years, and even before your engineering, through your 11th and 12th and all through your 10th education. But what does the industry need? The industry needs something different. The industry needs a changing over time. The industry needs to be met. So how do we so our goal here is to enable students to be able to address what the industry is looking for. So what kind of technology changes are happening in the industry? How do you evolve yourself to be there? How are you going to present yourself amidst so much of competition as to you being the person that the company needs to choose to employ? So that's what we say, we impact an individual's capability through their career by the power of training. So like I said, Emergeway's experienced trainers are from multiple domains. I mentioned this right in the beginning. Like for example, today we have in Dr. Prasad, who's basically an HVAC expert. I mean, his accolades are very long. I mean, he's an expert in project management. He's a black belt holder. He's a Six Sigma guy. He's an enthusiast. He does a lot of training. So people who have been into the industry has done a lot of ERP implementations, enterprise solutions. So our experience comes from multiple platforms and areas that allow us to understand what the industry needs. And so we become the best people to kind of train or give that knowledge to budding students who can appreciate what is coming. All right. So like I said, we work very closely with a lot of engineering colleges. I mentioned this right in the beginning. And so we provide students application-based training. This is an important thing, okay? So there's a lot of academics that you learn, but what is application training? I'll just give you a small example. If you were to if you were to be doing, let's say, a design on a CAD software, how many of you can do it in 5 minutes or 10 minutes? I know you guys will excel it because you have the speed, you understand the tools, you can do it very fast. But if I were to tell you I want you to design a particular pump or a motor, and allow you to figure out what kind of a material needs to be chosen, what kind of a design you should do to make it work efficiently. That's where application part comes inside, right? So that's what we basically train people on. So we have a lot of flagship programs, basically aligned to making students take certain roles. For example, there are design engineering roles that people want to take. So we train them on CAD tools and such things. There are a set of students who wants to be into manufacturing, where we give them CNC training, we give them all the manufacturing technologies and so on and so forth. And so there are many such areas or roles that students want to do. So we kind of, some could be in quality, some could be in service, some could be in maintenance, and so on and so forth. So in addition to this, we also have a couple of flagship programs that we actually take to industry as well. So we have a very deep industry connect as well. So while we work with multiple colleges, we are associated with hundreds of industries. Okay, they could be automotive sector, they could be oil and gas, they could be engineering services, they could be a typical IME manufacturing, they could be air conditioning, any kind of. So we also work closely with industry, where we try to connect the students who are trained by us to be able to choose their careers. Okay. Like I said, we also work with corporates and offer them a lot of training. Just like we do training for students, we offer multiple programs to corporates also, which could be as simple as there is a bunch of new engineers who have joined, and we're going to run them through a graduate engineering training program, okay, throughout an year. Or it could be, for example, like an Aditya Birla Chemicals, who have set up a new plant, and they want their people to be trained and their competencies managed over a period of time until they actually start the project. There's a build, operate, transfer kind of a mode. So we work with multiple corporates like that in their capacities. So I'd urge you to actually take a look at our website for more information, and always feel free. You have my email address. Always feel free, just in case you have any questions, you want to understand something more differently. You could be a college faculty, you could be a student, whatever it is, feel free to let us know. I mean, we'll always be able to help you. So some quick tips before we really get on to this program, while I kind of hand off this a microphone to Dr. Prasad. It's my pleasure to welcome you all to this live session. I really appreciate taking time, and you want to really learn and understand what's going on here. A few things that I would want to mention right up front is, if you are having your mobile phones, please put it on mute. As less disturbance as possible makes the training more effective. And we would rather take questions in the end of the session. We have earmarked a half-an-hour session for taking your questions in a very detailed manner. So if you have any questions, please drop those questions on the chat box, okay? And we will address them the moment we finish this training program, or we finish this whole exercise of presenting, and then we'll take one question at a time to kind of address those questions to you. All right. So that's all I wanted to say. I'll want to hand it over to Dr. Prasad. Dr. Prasad, like I said, is a person with a lot of experience in the industry. He comes with about 30, 35 years of experience. I've been very fortunate to be associated with him in the past in some companies where we worked together, where we used to implement ERP and CRM solutions. And then he's an HVAC expert. He has been into very large corporates like iGate, Voltas, and he actually has a very big capacity of role that he does in Pavni Engineers. And he's an expert in Six Sigma, ERP implementation. He's also a visiting faculty in a lot of colleges in Hyderabad and many other places. So he takes pride in sharing his knowledge. He has a passion to train. He likes working with youngsters. I think you guys are blessed to be part of this whole program. With this, I will let Prasad take over. Prasad, all yours, Prasad.
Good morning, everybody. Thank you very much, KK.
Thank you, sir.
It's always pleasure talking to students, sharing knowledge, learning from them. It's actually the other way around. Actually, for me, I learn a lot while I interact with the students because they bring the energy, they bring the curiosity quotient, which as adults we miss.
Right.
Well, um, I'll just start with a simple quote which I always love. A good teacher can inspire hope, ignite the imagination, and instill a love of learning. That's what I always believe. We don't train people; we always enable people to learn. That's something that I would try to do something today. What is air conditioning industry? See, there is an organization called ISRE, Indian Society for Heating, Refrigeration and Air Conditioning Engineers. So that is an organization which is a voluntary organization which works to improve the coordination between people and and the industry in terms of promoting air conditioning business. Well, what is air conditioning? First of all, let us get to the basics. What is air conditioning? Today, there is no place without air conditioning. That's all. That's a simple statement that we can make. 30 years ago, a refrigerator in a house was a luxury. 15 years ago or 20 years ago, air conditioning in a house was a luxury. Today, it is mandatory. It is necessity. Today, if you see house, 90% of the houses are with at least one or two air conditioners, and also, at least one large refrigerator at home. And if you want to go to movies, theaters, or malls, or places outside, any shopping, anything, you don't prefer now a shop without an air conditioning unless it's just a small shop that is coming up. So air conditioning has become a necessity. 30 years ago in the industry also was looking at air conditioning as a service, as an utility basically for the people to look at. It was an utility service where there used to be a maintenance engineer, and it is something that they were there. Only a few organizations used to have air conditioning systems, and there were specialists to maintain that system to ensure that it is working well. But with the technology grown up, with so much of systems grown up, air conditioning has become a necessity, and there are a lot of things that the industry is now providing. Now, as per ISRE, let us look at why we have to understand the air conditioning systems and looking at air conditioning as a career opportunity, as an entrepreneur opportunity, why it should be looked at. Let us look at it for a few more minutes. HVAC and our industry is the fastest growing industry. According to ISRE, according to a survey done, it is the fastest growing industry. It is at par with IT, if not less than that. So if it is at par with the IT, and no other industry can say that they are growing as fast as this. Central air conditioning system, infrastructure, IT, ITES, office complexes, retail, healthcare, hospitality, banking, manufacturing, you name it, you have the air conditioning systems. In fact, the whole discussions were there. There were a number of panel discussions, there were a number of webinars happening on the air conditioning systems, how they need to be managed, how they need to be maintained, how they need to be prepared for the COVID-19 effects. So this is a kind of industry that is growing beyond the normal. So that is the central air conditioning system. If you look at the package air conditioning system, all retail, small, medium enterprises, commercial establishments have packaged air conditioning systems. If you go to any retail small showrooms, you have package and split air conditioners. VRF, excuse me. VRF systems, these are the fastest growing segment. These are also called DX systems, extension of packaged air conditioning systems, I can say, but with a lot of control, which we will see during our presentation. Multi-story residential office buildings, hotels, hospitals, and there are many more. You are seeing now the VRF systems. Room air conditioners. These are predominantly, I don't see many of them now in residences now. They are also replaced with the split air conditioners or the VRF systems, and very soon room air conditioners will go out of coverage area. So they will go to oblivion. Residences, small shops, small offices have these room air conditioners, but today there are more IoT based and totally automated remote controlled air conditioning systems are available. So these will be replaced by them very soon. Cold chain products and systems, agriculture, ice cream, hospitality, supermarket, processed foods. I don't know how many of you are aware that, India is the largest holder of cold chain systems, cold chains, cold storages. These are, India is the largest in terms of having the cold chains. So, which means that, we have so many cold storages available, and we have the largest the coastal line with us. So that is basically for processed foods, fish, and other things. And we have agricultural products which need refrigeration. So the entire cold chain, right from the farming to the kitchen, there is a cold chain process that is required, and there is a huge growth in this particular area. Hospitality, of course, there are so many things, and supermarkets and all will form under the supply chain of the cold chain products. So please do look at HVAC under as a career option, because this is something in the next 30 to 40 years also will keep growing. If you look at the outside temperature, the ambient temperatures are going up very high, and you know we don't have a very good fresh air outside. We have polluted air outside. So in order to breathe fresh, in order to breathe happily, and also maintain proper temperatures, you definitely need air conditioning systems. And in future, this is only going to grow up and up. And I would recommend all of you to consider HVAC and our industry as a serious and important aspect, and don't underestimate this. Look at the size. This is growing at 10% every year, and only Indian population is 17.5% of the total global population, and out of that, only 2.8% is the Indian global market as of now today. But it is going to grow up to even 10%. Then it will be 5 times the market that we are talking about, which is a huge growth. And very soon, I'm sure that things will be shaping up very fine. Now, again, when it comes to air conditioning as an industry, a lot of research has been happening. A lot of work has been happening in optimization, in energy saving, energy consumption, energy optimization, and all these areas. Why? Because almost about 50 to 55% of a building energy consumption is air conditioning or related to HVAC, which means that you require um, that kind of power bill to continuously run air conditioning systems. So if you have to do that, then the power bill today is about almost about 9 rupees for the industrial unit, and it is not going to be cheap. So we need to be cautious. We need to have the energy conservation, and there are a lot of research associates working on the research of many of these products, services, and also the systems that we are developing on. We are also looking for alternate energy sources for air conditioning systems, and that means there are a lot more opportunities in every field of air conditioning system. Now, what are the potential industries that you can think of as an engineer, as an air conditioning specialist? Okay. So HVAC and our manufacturers, there are plenty of them. With the Make in India coming up, I'm sure that India will be flooded with a lot of big companies like Hitachi, Daikin, LG. All these companies have already have shops, already have factories out here. But today, most of them are doing only assembly in these places, but I am confident that in the next 3 to 4 years, that will be completely manufactured here, which means that there will be so many ancillary units that are required to support these manufacturing units. So please look at the volumes. What are we talking about? And when they have, because of COVID or whatever, if China is not able to support these people, what they are doing currently, even if 20% of the business moves out, even if 20% of the factories that move out of China to come to India, which we are talking about, billions of dollars of investment in terms of manufacturing, which means again there are so many ancillary units, so many requirements for a lot of entrepreneurs who will be supporting these large organizations. Huge opportunity. Now, let us look at, there are contractors and dealers. Every year, thousands of tons of air conditioning is being erected into the systems, buildings, commercial buildings, offices, everything, wherever that is there, hospitals, you name it, you have air conditioning system. And contractors and dealers are executing those projects. Consultants, there are a few consultants available today, but there is a big gap for good consultants with energy efficiency knowledge, right from the architectural designs to the central air conditioning systems. There is a dearth of consultants. Project management companies today, the size of the projects is going very high. In fact, HVAC is now coupled with all MEP projects, mechanical, electrical, and plumbing projects, and it is a contracting. One single contract is EPC kind of a contract that are being now developed, more or less. So project management is going to be one of the most critical things in the coming future. I hope I have given you enough understanding about all these things. So if any of you want to have any questions on any of these things, please do share in the questions in the chat box. We will look at those questions. If you look at any engineering today, it is always a multidisciplinary field. There is no single product which is derived from only one engineering discipline. Same is the case with the HVAC and R. HVAC and R deals with electrical engineering, automation, electronics, material science, IT, instrumentation, environmental engineering, IoT, whatnot. There are so many things that are coupled. Civil engineering, architecture, mechanical engineering. So it is not. It's a myth that it is only mechanical engineering field, and I'm still surprised. I'm shocked as well that even today in many of the institutions, universities, HVAC is still as an optional subject rather than a mandatory subject. That pains me as a professional, because that was the case about 30 years ago, as I told you. Even today, it is a necessity, and that is the fastest growing industry. But unfortunately, even today, it is still an optional core subject rather than a core subject in many mechanical engineering, even for mechanical engineering students. So I hope that it will soon get revised. So um, let us look at what is HVAC and R mean. HVAC and R is heating, ventilation, air conditioning, and refrigeration. So AC and R is what we used to call earlier. Now it is heating, ventilation also are very, very important, particularly in places like North India where the cold climate is there, the heating becomes one of the most critical things. And when you are talking about the 24 by 7 for IT and hospitals and many other organizations where you require 24 by 7 air conditioning, the heating also becomes very, very critical. Ventilation again, one of the very prominently spoken word in the last few weeks because of the COVID, how the air is passing, air is circulating the COVID particles and other things, the virus, how it gets transmitted. So ventilation has been discussed quite a lot in the last few weeks. It is ventilation of air is not a load on the room, but it's a load on the central cooling equipment. But ventilation also helps us to maintain positive pressure within the building. And in fact, when you are talking about isolation rooms for patients in COVID patients and other things, you have to maintain negative pressure in the rooms. So how do you make it? So that means that, a lot of scientific work needs to be done. The design is required to make sure that you have either positive pressure as or negative pressure as required by the application. With this introduction, let me jump into the air conditioning system. Air conditioning system for comfort of the people. I want you guys to write down, on the chart box, what is the temperature at which, what are the comfort conditions according to you? What are the comfort conditions according to you? Uh, KK, if you can just tell anybody mentioning, then I will go forward.
Guys, you can type your inputs on the chat box.
What are the comfort conditions for the people? At what temperature or what are the comfort conditions that you feel?
Okay, Infant John says 18 degrees C. Adit says 25 degrees C.
Okay.
And then Ahmed says 25 to 30 degrees C.
Okay.
Lot of people between the 22, 25. Dinesh says RH 60 and 25 C.
Very good. Very good. Excellent. See, the whole point I was trying to, the reason why I asked is it is not just the temperature alone, which makes people comfortable. The temperature along with the humidity level and slightly the air movement, appropriate air movement will make a person feel comfortable. Typically 24 degrees C plus or minus 1.1 degrees C and 50 to 60% RH is considered as the comfort conditions. In the last few weeks, which we have been talking about because of the COVID reasons, I strongly recommend, being a member of history and having participated in many of the seminars, or webinars, I strongly recommend that you maintain the temperature above 25 degrees C. Don't drop below 25 degrees C, at least during until the COVID this thing is over. 25 degrees C and 60% RH, 50 to 60% RH is the ideal condition during this period. Even up to 30 degrees C is better when you have COVID around. But anything, 18 degrees C, my dear young man, is not a comfort condition. It is a freezing condition. You will freeze, except in data centers and specific requirements of IT. You don't go for 18 degrees C. Okay, so that is the temperature, humidity, and air movement. Airflow is very, very important, as I told you already. Air purity is again another important aspect of the air conditioning systems. When we are designing air conditioning systems, we keep in mind about the air purity levels, the air filtration levels. And for example, if you have a hospital air conditioning, you do the filtration level up to even zero point 0.3 microns in the operation theaters, which means that at that particular zero point 0.3 microns, we are able to remove as much bacteria as possible at that level. So, and there are clean rooms where you maintain uh, class 100, class 1000, like that. And also, when you the normal air conditioning systems, normal AC systems that we use, we have about a 10 micron filtration level or 20 micron filtration level. Depending upon the requirement, we go to 5 micron or even lesser than that. That means that we are trying to make the room as clean as possible. Again, the noise level also we keep as low as possible. Less than about 30 to 40 decibels between 30 to 40 decibels is what we generally maintain. Now let us look at basic refrigeration cycle, which again, many of you have seen this basic refrigeration cycle. I start at the evaporator or the cooler, here listed here as a cooler. And in the cooler, the low pressure liquid is entering. Low pressure, low temperature liquid enters the cooler or the coil. It takes the heat surrounding to it, and the low pressure liquid becomes low pressure gas at the same temperature. That means it changes its phase. So liquid changes to gas, and pressure also remains the same. Now that low pressure gas, having taken away the entire heat, the refrigerant has changed its phase, and the air is getting cooled here, and the cool air is circulated to the room. And this refrigerant, which is a low pressure, low temperature gas, goes through the compressor. And the compressor, it does compression. It increases the pressure as well as the temperature. Now, the question here is, why should you use a compressor to increase the pressure? It's a very, very simple reason. You have to remove the heat, whatever you have taken away from the heat here. The refrigerant is now in the gaseous state and at a low pressure. In order to give away the heat to the ambient temperature, to the atmosphere, it has to raise the pressure above the ambient. Then only you can remove the heat from the condenser or the refrigerant back to the atmosphere. And that is the reason why you use an external agency called compressor, which will increase your pressure. The high pressure gas then goes through the condenser, and being the outside temperature being less, or the outside temperature being lower than the refrigerant temperature, the heat from the refrigerant takes it away, and it condenses basically, and uses again latent heat here also, changes the phase from the liquid, from the gaseous phase to high pressure liquid. But the high pressure liquid cannot be used to take away the heat from the room. So it has to be again lowered in terms of its pressure to enable it again capture whatever the temperature or the heat from the room. So that is why you use a control device, which is also called an expansion valve. And in small refrigerators, you use a capillary tube. In large systems, you use expansion valves. And maybe in the VRF systems and other places, we are using electronic expansion valves. Whereas for normal application, you use thermostatic expansion valves. Hope this is clear. Again, just for the sake of it, I will repeat it with a slightly better drawing. The mixture of a liquid and vapor comes to the evaporator, which is again a heat exchanger basically. It may be a coil, it can be a tube and a shell and tube heat exchanger. the liquid goes through this, and the liquid becomes a superheated vapor and enters a compressor. And the hot gas from the compressor goes through a coil at the condenser, and the desuperheated and saturated vapor becomes saturated liquid, and then becomes a subcooling liquid in order to increase the refrigeration capacity, or in order to increase the absorption of the refrigeration capacity. And again, it goes to the expansion valve or thermostatic expansion valve. It is shown here, and it goes. This is a continuous cycle. So this is see, this is at the evaporator you have a heat exchanger. At the condenser also you have a heat exchanger. A very simple cycle. It's a continuous cycle. Same thing explained, in a pH chart, pressure enthalpy diagram. So A to B is evaporation, B to C is compression. This is a superheated state. Maybe you can call this as D dash is a superheated. It go to D. It may even go to subcooling, D double dash, and then comes here, and it is a continuous cycle. So another way of representing the same thing, you have a supplier. Supplier is sent at 55 degree F. You want to maintain 75 degree F or 24 degree C. Then you need at least the air to be supplied at 55 degree, and that means that around 20 degree F delta T you are supplying it, and that air will mix with some fresh air and goes through the conditioned space, becomes keep the place cool at 75 degree F, which is again about 24 degrees C, and that is coming back as a return air that again goes through the air handling unit along with the fresh air, and this cycle keeps continuing. This cycle is very simple. This is the air side cycle. And how the air is supplied to the conditioned space, you may use ducting, you may use various methods of sending the air distribution systems. Now, from where is the air getting cooled here? Now, air is coming at 100 degree F and mixing with 75 degrees C, which means that air is almost about 82 degrees C F here. So where is that getting cooled to 55 degree F? So it is getting cooled in the evaporator, because in the evaporator there is a chilled water system. Chilled water is again a secondary refrigerant here, secondary refrigerant. You can use a chilled water coil here or a DX coil here. Here the example shown in this drawing is chilled water, which is a secondary system. The chilled water will come at about 45 degree F and takes away the heat and becomes about 53 degree F and goes to chilled water, return at 53 degree F, goes to the chiller. So this cycle is the chilled water cycle. There are pumps which are pumping continuously from the chiller to the different air handling units. So this is another cycle that keeps happening. In the chiller, there is a refrigeration cycle, vapor compression refrigeration cycle. Earlier we have seen the chiller to the compressor to condenser to evaporator coil, and then to chiller. This is the same thing that keeps happening within the water cooled chiller. So now there is a cooling tower also, and the condenser heat is rejected to atmosphere. Now, fundamentals of air conditioning, again, there are several things that you need to understand here. Heating is a process of adding thermal energy. Cooling is a process of removing thermal energy. Humidification, whenever you are talking about air has two properties. One is temperature and another is humidity. There is moisture content that is there inside. So the moisture, water vapor to the air in the conditioned space should also be maintained. So dehumidifying, if there is more vapor, you have to remove it. If it is less vapor, less moisture, you have to add it. So our maintaining, what we need to maintain, the RH is around 50 to 60%. So cleaning is another important process, the process of removing particles, biological contaminants, pollen, anything that is required. So you use different types of filters to do this. I would strongly recommend you to read MERV, MERV filters. That will help you to understand what kind of different filters that are available, right from the pre-filters to the HEPA filters. All right, highly efficient particulate air filters, HEPA filters. So ventilation is a process of exchanging air between outdoor and conditioned space. This we have seen already. Air movement is very important. That also we have seen. There are a few definitions that you need to understand. I don't want to go in detail into those things. Dew point temperature is the temperature at which the water vapor in the conditioned air changes to liquid, and sensible heat, you know very well, where there is only change in temperature, not change. There is no change in the phase. Similarly, latent heat, there is change of phase at the same temperature. Right. So let us look at classification of AC systems. Chilled water system, all air system, all water system, air and water system. And you have DX system, window split and VRF systems, and evaporative cooling, single stage, two stage, three stage. See, evaporative cooling basically, even a cooling tower also uses the same principle. And I don't know how many of you used uh, coolers at home, air coolers at home, desert coolers at home. Can you just say how many of you used and what kind of coolers you used at home? What is the principle? Can you put it in the chat box? And KK, can you just read if anybody has?
Yep. Did you hear the question? How many of you have used desert coolers? Have you used water coolers?
Air cooler.
Air. Maybe this part of the world doesn't use air coolers at all.
Yeah, I know. How many of you have seen pot in summer? How many of you use pots for holding water? What is the principle of cooling in a pot? Any response?
Nope.
Okay, great. So the principle is very simple. Even if you go to any of your petrol stations, petrol bunks, you put small 1 drop of petrol into your hand. Uh, the petrol evaporates very quickly, and your hand becomes cool. Why is it so? Because it is the principle of evaporation. So same principle is used in pot, there are the pores in the pot, holes are there, small holes are called pores. Pores are there on the pot, and this water slightly evaporates through those holes, making the inside water cooler than the outside. So that is the principle of evaporative cooling systems. And in places like Hyderabad, Jaipur, and desert areas where the relative humidity is very low, less than even 25%, 30%, then there is a scope for using water itself as a cooling substance. So using water, you circulate water and sprinkle it on the airflow. Then some of the water gets evaporated and thus cooling the air which is passing through it. So this is the simple principle of a desert cooler or the evaporative cooling system. The only limitation is it can cool only up to the air becoming saturated. At what temperature air gets saturated? It is nothing but your wet bulb temperature. So there are two temperatures which are there: dry bulb temperature and wet bulb temperature. Wet bulb temperature is the capacity of the air to hold the moisture. So whatever is the balance capacity that is left over is, that is the ability to hold the water. That is your wet bulb temperature in a very crude sense. So in a simple way to understand basically. So we can only cool using evaporator cooling system only up to the wet bulb temperature. So, which is again, slightly higher than your comfort condition. That is the reason why, a lot of organizations after a lot of research have come out with the 2-stage and 3-stage evaporative cooling systems. So in those cases, they reduce the wet bulb temperature itself through other one more phase where the reduction is sensible cooling, and then goes to the evaporative cooling. So which allows the temperature to be reduced below the wet bulb temperature also. So that is called 2-stage evaporative cooling and 3-stage evaporative cooling. There are companies like ATE, which was earlier HMX. So I would strongly recommend you to go through that website, HMX or ATE, where or GECO, or there are so many companies which are making now the 2-stage evaporator coolers or 3-stage evaporative cooling systems. Now, what is DX system? DX system is a direct expansion system. That is what we use in our homes, split units or package units, or even VRV systems. All these are direct expansion system, which means that the cooling coil, which is there in the room, taking out the heat from the room, the refrigerant flows through these coils directly. That is why it is called direct expansion. Alternatively, instead of refrigerant directly passing through, there are the chilled water is used to circulate it. That is called the chilled water system. So in the chilled water system, there are different types of things that are there. So you have single zone, variable air volume, and you have central chilled water systems and things like that. This is vapor absorption system. I don't want to confuse you with explaining this, because it's altogether a totally different system other than the vapor compression system. So depending on the type of criteria, you select either centralized system or a decentralized system. See, some of the criteria can be, what temperature, what humidity, what space and pressure requirements you are maintaining, what are the capacity requirements you have, what is the redundancy that you have, and if there is any special requirement that you have, you decide on the either it is centralized system or decentralized system. So what are the advantages of centralized system and decentralized system? Centralized system is high cost, high capital cost, considering longer equipment services like to compensate. And the decentralized system like VRV systems and all are affordable capital cost. More significant energy efficient primary equipment proposed operating. Low energy efficient primary equipment compared to centralized. Again, I would not compare like this. I would also say that it comes out with some caveats. Currently, there are many systems which are more efficient significantly from this also. So definitely, I would say that these are also highly efficient systems, right? Now, looking at what is the refrigerant properties of refrigerant properties, safety, toxicity, flammability, and effectiveness of refrigerant cycle. That means ability to have kilowatt per ton, lesser volume per higher kilowatt per ton, and compressor displacement, all these things. So what are the refrigerant? As you know that because of the ozone depletion layer, ozone depletion. So ODP being high, a lot of refrigerant have been replaced. The CFCs have been replaced and HFCs have been replaced. So now they are replaced with R123. Now is replacing R11. R134A is replacing R12 and R22. R404 and 407 replaces R22. R507 replaces R502. The first two R123 and R134 are used mainly in centrifugal compressors, and R404, 407 are used in both screw chillers, screw compressors, screw chillers, and scroll chillers as well. Hope you got the point here. So now what I will do is I will quickly run through some of the equipment that we use practically, and then we will take the question answer session. So if you see this, this is the air conditioning zone. Okay. Please pay attention to this. This is the air conditioned zone. You are supplying air using a fan. This is called an air handling unit. In the air handling unit, you have a coil where the chilled water comes in at a higher temperature, goes out at a lower temperature, and there is a fresh air coming up, and the recirculated air is coming back, which is going through a filter here, and that air is going through the coil, gets here through the filter, it is getting filtered, clean, and getting here, the air is getting mixed, recirculated air is getting mixed with the fresh air. The clean air is going through the coil, where it is giving up its heat to the coil, and the lower temperature supplier is now pushed using a fan into the comfort zone. This is an air distribution system. Air distribution system uses ducting, grills, dampers, vanes, and so many things. I will show some of the pictures so that you can understand it. And in the room, the air is distributed very well, properly, so that it goes to all the nook and corners, and maintained well. As we see, the air movement is one of the important criteria we design it, and the air velocity is also another important criteria. You don't want a heavy draft of cold air and facing you. At the same time, very low velocity also will feel you make sweating again. So both things are not required, not correct. Many times I have seen some of the dealers, because they want to sell their equipment for large areas also, they sell window ACs or split ACs, which don't give you cooling. Instead, they generate hot packets of hot air, which are more uncomfortable inside than outside. Even though they have AC units working, they are more hot inside than outside because of improper mixing of air. So this is the written air is getting recirculated. Some of it is getting recirculated, some of it is getting exhausted, and some fresh air is always added. So ventilation is always taken care, and fresh air is always added. So the question comes here: why can't we have 100% fresh air? Why we should be recirculating air? So if you use 100% fresh air, you require at least 5 to 6 times the air conditioning capacity that is required to cool the same space. 5 to 6 times. That means if you have 1 ton with the recirculated air, you need at least 5 to 6 tons of air conditioning system to with the 100% fresh air. And whatever is the temperature, you are only wasting the energy here. So what we are doing instead is you are reusing that air, recirculating at least 80% of the air, mixing with 20% of fresh air, and that 20% is exhausted here, and this makes an ideal combination for the safety. So cooling devices, chillers, VRF system, cooling towers, air handling units, fan coil units, evaporator units. There are a lot of equipment that even if you talk about one equipment itself, you can talk for about hours together. But since we have short on time, and that is not the requirement at this point of time, my interest today is to create an awareness about air conditioning systems, so that you can go and do your diligence. And if there are further queries or further areas where you want to understand, we can take up those sessions separately again. Look at the system components. We have chiller, we have cooling tower, we have pumps, centrifugal pumps, monoblock pumps, end suction pumps, supplier fans, exhaust fans, relief fans, air and fresh air fans, axial flow fans, centrifugal fans, ducts. You have aluminum ducts, GA ducts, then you have puff insulated ducts, dehumidifiers or humidifiers, boilers and heat pumps. There are so many controls: thermostats, humidistats, energy meters, then flow meters, carbon dioxide the sensors, so many things that are there in the controls, mixed air plenum, outside air control, air filters. Air filters is another area where a lot of questions are coming up, a lot of thoughts are being, a lot of questions are asked about the filters today because of the virus, antivirus, and things like that. Return air system, cooling and heating coils. The air handling unit contains both the cooling coil as well as a heating coil. Cooling coil is used to cool and dehumidify the system, whereas heating coil is used to heat and humidify the system. That is used during the winters. So rooftop condensing units, chiller, condensing water piping, so many and so forth. Okay. Now, well, let us look at the major components like the chillers. Chillers are the major components. We have vapor compression chillers, vapor absorption chillers. Again, vapor absorption chillers, right now I'm not going into it. Vapor compression chillers, when we started working in Voltas, we knew only reciprocating compressors for majority of applications we used to do. Of course, there was centrifugal chillers very sparingly used in India, which were manufactured only outside India, and imports were not so frequent at that time. So reciprocating compressors were used in majority of the applications. But they are totally outdated today, and not many use reciprocating compressors unless they are continuing with the old equipment right now. Today, we have scroll chillers, screw chillers. These two are mainly used for the low and medium level installations. Scroll chillers are for the, all our split units, lower level units. We use scroll chillers. Very, very comfortable to use and energy efficient. Screw chiller comes in between centrifugal and scroll. Above 100 tons, you use screw chillers. So depending on the type of condensers which we use, water cooled condenser or air cooled condenser we talk about, or even there is a direct cooling evaporative condensers. So that's what we're talking about: screw compressors, centrifugal compressors, air cooled. When the air is when the heat rejection is directly to atmosphere using air cooled coils, then it is called air cooled condenser. When the heat rejection is through the condenser water here, and that water again goes to the cooling tower and get the heat is rejected to atmosphere in the cooling tower. So those are called water cooled. When the water is available in plenty, then you go for water cooled. And when you don't have enough water, then you go for air cooled chillers. So this is again, another example of air cooled and water cooled. Water cooled, additionally you have cooling tower, because whatever the condenser, you are removing the heat, and that heat again is going to get removed in the cooling tower, and that cool water from the cooling tower is flowing directly again here. So that's the only difference. Now, the pumps, there are many pumps. Pumps itself, you can have a discussion for at least 2 hours or 3 hours. Pump curves, pump efficiency curves, and all very, very interesting. You have monoblock pumps, you have end section pumps, horizontal split casing pumps, vertical inline pumps. There are so many pumps that are there. These are used both to pump primary water, primary chilled water system, or secondary chilled water, or condenser pumps, or you have air separator pump. There are many small applications like this in the air conditioning systems. So hydraulics will play a major role when you are talking about air conditioning system. VRF system. VRF system is one of the most prominently growing equipment in the recent past, particularly in the last 10 years. It has taken away a lot of market volumes, almost about 30%. It has taken away from the chilled water system. So you have 4-way cassette type. These are all, the indoor units. The 1-way cassette type, ducted type. These are indoor units. Indoor units basically consist of an evaporator and a filter. Whereas this is the outdoor unit. Outdoor units will have all the compressors, connected through the refrigerant piping and the expansion valves with the indoor units. One of the key advantages is you can combine two or three or multiple indoor units to one outdoor unit, which is not possible with the one split unit or air conditioning normal split units. That is the key difference between VRF system and the other systems and other DX systems. In the VRF system, also one more advantage or one more key differentiation is that we use electronic expansion valve here, which understands what is the load on each of the indoor unit or the evaporator units, and then accordingly supply the refrigerant passage through that evaporator units. This is a typical example of a large VRV. It is also called VRF, variable refrigerant frequency, or VRV, variable refrigerant flow. Very interesting. It is can be automated. A lot of controls are there. A lot of programmable controls are there, and in the it uses a lot of technology, of course, very. But only thing you need to be cautious with this system is all through the building, wherever the evaporator is there, the refrigerant is flowing through that. So any leakage in the refrigerant will be, causing that the refrigerant is sometimes flammable. So you need to be careful. Evaporator cooling systems, we have discussed about it. So this is what I was telling you, HMX or ATE, it is now called ATE. So you look at it, initially it reduces the sensible cool, using the sensible cooling it reduces, then uses the evaporator coil, thereby reducing the wet bulb temperature. Insulation, a lot of insulation material is used both for heating and cooling. So please go through that. This is you have expanded polystyrene, or then you have nitrile rubber, you have fiberglass. Okay, so puff is used again. So there are many insulating materials. Insulating material itself is one interesting class altogether. This is used for both the chilled water pipes as well as the ducting, supplier ducting, returner ducting, air handling unit. Wherever there is a temperature difference between the ambient outside and inside, you use insulation so that you don't lose the heat just like that out to outside. So we have cooling towers used with water cool chillers suitable for hospitals. Wherever there is a chilled water system, it is always coupled with cooling tower. Fan coil units, you might have seen these fan coil units mainly in hospitals or in hotels. Hotels definitely in each room of the hotel, you have one fan coil unit. You might not have seen it. It is inside the false ceiling, so you may not be able to see it. But that is how you have the system. Right, sir. So there are ductable splits and things like that. So what I will do here, KK, is I will stop here and take questions here from here.
Okay.
Because it's already 11:10, and
Right.
I'd like to take questions so that we can answer through the questions.
Absolutely. So, yeah, I mean, I already have a question on the chat box. Okay. What do HVACR industries look for in a mechanical fresher? What topics must a fresher be well versed with? This is from Adit.
Interesting. Adit, not only air conditioning industry, but any industry, we don't look for any great technical skills from a fresher. What we need is, we know that very well. Whenever we go for interview, we know very well that if you are at least above 60%, that means you are both hard to understand the basics. You have the core knowledge of whatever you studied, and that is good enough for us. But what we certainly look for is attitude to learn, as an attitude to deliver, attitude to improve yourself every day. These three things, if you have, coupled with the curiosity to learn technology, to learn new things in in the domain that you are working, definitely that is enough. One or two projects that will help us, whatever the projects that you have, will certainly help us, to understand what kind of work you have done. Hope I answered your question.
I want to hear welcome Dr. V. Ganeshan. Mr. Ganeshan has joined us now. And in fact, he has been one authority in this subject. Prasad, I mean, with your permission, I'd like to kind of give him a small introduction. And he also will be able to take a lot of questions, because he's been, I think he has about 35 years of experience, and he's, master's in power systems with a bachelor's in electronics engineering. And he spent a lot of time, in academics. He's been a principal of few colleges, and he's been one of those privileged people to have received awards from chief ministers and prime ministers of India. And he spent a lot of time traveling and being outside, especially in Saudi Arabia, where he has been responsible for, implementing a lot of these air conditioning systems and, heating systems and all that stuff. And we are very privileged to have him today. I mean, today, as of now, he's actually the deputy director of placement and training from Dr. MGR Education and Research Institute. We are very honored to have you, sir. And any questions? Obviously, we have the privilege of Dr. Ganeshan to take them as well.
Yeah. Can I talk on that? Or?
Yeah, sure. Please, sir.
Okay. It is a very interesting subject, and you have elaborately been discussing about this subject. And in fact, I liked this subject very much. That is why it will be very useful for the student. And most of the students, even though they are mechanical engineering domain, they are not actually knowing the fundamentals of air conditioning. When I ask this, simply I ask a question, why the hot air is coming out from the outside? Then they will say, the room is very hot, sir. From the room, the air is pumped out. That is what they are saying. That was the knowledge they are having with the air conditioning. Because they are actually forgetting that there are one blower and also one fan is there. That is inside air is sucked and only put inside, and outside air is sucked and sent it outside. So there is a fundamental principles that you have been very good, very well explaining about the evaporator and the condenser, the high pressure and low pressure, and also the various other things. How the heat can be taken away so that the thermodynamic principles are properly adhered to, so that the cooling is, we are getting a much more cooling. So I am very happy for the invitation, and this is the message that I wish to take. The air conditioning concept, you people have to learn, especially the students have to learn, and this will be very helpful for taking up an entrepreneurship also by your own, and also joining a company where you will also be knowing, you will also have to know something about air conditioning, because it is very important, because you have got an abundant job opportunity here in the air conditioning field. I'm thankful for this kind, introduction that is
Thank you
being
very
made
much,
by
sir.
me.
It's a pleasure to have you on board. It's a pleasure to
Yes.
have you on board. So I'm going to kind of unmute Ahmed. Ahmed, you had a question. Please go ahead.
Yes. No, sir.
Hi, sir.
Yeah,
Hello?
go ahead. Go ahead, Ahmed. You had a question.
Sir, my doubt is I actually started taking this Revit MEP and HVAC classes after my relatives advised me, because most of them are in Arab countries. There, they said it is an evergreen field. The HVAC is an evergreen field. There is many scope there in Arab countries.
Mhm.
So my
Yes.
doubt is there really a good scope in for HVAC engineers in Tamil Nadu? Is there any good big companies who really need HVAC engineers, who really recruit HVAC engineers, sir?
Yes, definitely, sir. Because air conditioning engineers are required in Arab countries as well. In Saudi Arabia, there have been a lot of engineers from India, especially the diploma holders who had first-hand information than the degree holders. But now the degree holders has got the added advantage for designing. and also for making much more concept-wise, they are making it very clear where to put the air conditioning equipment, which height, and which are all the systems that are to be taken care of. Design how much energy losses they can allow it. All these things they can make it very fantastically well. I mean, how much the air handling capacity it should have. All these things, if they are knowing it, then they have got an abundant opportunity in the United Arab Emirates country.
Yeah, I will also add a few more things there. Sir, thank you, sir. You have given the right answer there. There are opportunities are in abundance. There is no doubt about it. But my take on this question, not only here, anywhere I go, a lot of students ask the same question. Sir, will there be opportunities? Will there be opportunities? I strongly say opportunities will always be there for the right people. But are you right person to take that opportunities? That is the question that you need to ask yourself. How many times you can change yourself to the market conditions? It is not possible. Market conditions keep changing. Nobody expected what is a market, how we could be like this, 6 months back, everybody was in a different world. Today we are in a different world. So don't ever try to look at only opportunities outside and then convert yourself. No, that is not something that I would suggest. I would strongly recommend you have your strong base of your fundamentals. You have your strong base of your capabilities. You have your base of your self-confidence. Take it, Mr. Ahmad, if you don't have confidence on yourself, don't expect others to have confidence on you. The market conditions will not change anything for you. Your confidence can change the market conditions. Be clear on this, and I would strongly recommend to all of you, as I said in the beginning of my session, there is a huge market, but are you ready? Think about it, and I hope, I'm little blunt on this, but that is a message that I would like to give it to the youth. Youth is the future of this country. You can't be just depending upon, my uncle told me, my brother told me, my daughter told me, my sister told me. You have to have confidence on yourself. Sorry, I was a little blunt, but I hope I answered your question.
Prasad,
Yes, sir. Thank you, sir.
Thank you so much, Prasad. In fact, what you brought about is something that's much larger, whether it is heating, ventilation, air conditioning, or whether it is an automotive sector, or whether it is oil and gas. Opportunities are in plenty. That's what we keep when we talk to colleges, when we address students, we keep saying there is plenty of opportunity. We can keep talking about stories of Dhirubhai Ambani, stories of so many people that have become so big. All they had in common was a dream and the perseverance to go there. How much are you committed to it? How much are you going to make use of it? How do you see reskilling process is something constant today? I mean, you've got to constantly be in touch with what the industry needs. And that's the only, what do you call, there's a saying, change is the only constant. That's how it is. So, yeah, I mean, everything is an opportunity. Maybe like you just pointed out, Ahmed, opportunities in Middle East is much more, obviously, because without air conditioning, people will die there. It doesn't mean that opportunities in India is minimum. Now, everything, how many offices have you been into which is not air conditioned today?
Mostly everything is air conditioned,
Absolutely. So there is abundant opportunity.
Yeah.
Especially in maintenance, in service, in erection, commissioning.
Okay, with your permission, I want to ask one more question.
Yeah, please.
Ahmad, you want to go to Saudi for opportunities, or the other countries for opportunities, but you want to limit yourself into Tamil Nadu. Why is it?
No, nothing like that, sir. I just
so
want
many opportunities.
really
Precisely
good
the
scope in India.
mindset that we need to change. Okay, that's all I wanted to say. Thank you.
Thank you for that. Any other questions? Interesting question there. Yeah.
Thank you, sir.
Any other questions? You guys can unmute yourself and ask the question if that's easier rather than typing it. I have one question from Dinesh. if recirculation and fresh air is mixed, what are the measures to be taken to remove CO2 from recirculation air? Dinesh, you may want to unmute yourself to ask this question if
No,
that's
no, give it to the sir. No, sir can answer this.
Yeah, sir, Mr. Ganeshan?
Yes, yes, sir. What is the question, sir?
If recirculation and fresh air is mixed, what are the
Fresh air?
measures to be taken? Fresh air is mixed. What are the measures to be taken to remove CO2 from recirculation air?
Yes, but of course the filters. We have also had a lot of researchers on fresh air handling. You know, especially in you meant to say the industry or in the house. In the house, there are two things. You know, one is the split air conditioner. The other one is the window air conditioner. Window air conditioner, it is very complex. Unless the maintenance is proper, I mean the filter maintenance is proper, then the fresh air, the CO2 maintenance will not be properly be monitored. Suppose you open the door and there is a person who is doing some kitchen work, onion work or something like that. The smell comes inside means it is really difficult to take away the smell only after certain say 15 to 20 minutes the smell goes off because the filtering is working. So the filter is very important. Now modern filters have come into the market, and there are also extensive researches that are going on, bacteria removal, this one removal, all these things are there. But in spite of it, the filters have to be periodically cleaned and periodically replaced. Then only that CO2 handling will be perfectly made.
Okay. In addition to that, sir, actually Ganesh sir has given a wonderful answer. Dinesh, when we are doing the heat load calculation, we take the fresh air requirements into consideration. The fresh air requirements, when we are taking into consideration, the air filtration and the infiltration also we take into consideration. And when we see that number of air changes per hour we consider the CO2 also removal from the whole pot. That means some of the air is getting exhausted and some of the fresh air is getting taken into that. And the combination at using those number of air changes per hour will automatically set the reduction in carbon dioxide. And what Ganesh sir told is very simple. You know, you have filters anyway to do the cleaning. And in the room air conditioner room, what we do is keep slightly one window open so that you know you don't have the CO2 getting accumulated within the. Thank you.
Fantastic. Any other questions? People can actually unmute themselves and ask the question too, if that's easier. Thank you, Dinesh.
Sir Ganesh sir, thank you very much, you know, for joining
Yes,
us.
I am also very happy, sir, for making me involved in this program. I'm really very happy. Thank you very much for this nice thing. I hope the students also will get it. There are so many formulas that is about fresh air and which requires a lot of debate. I mean, return air temperature, so outside air temperature, mixed air temperature, all these things are also to be considered. I just only told about the inside the house. There are certain cases which are industry oriented, means it will be a different air conditioning design model we have to make.
Yeah,
That's a very
we
long.
have one question, sir. Here we have one more question here.
Yeah, Venki, can you please go ahead with your question?
Yes, sir.
Yes. Sir, sir, recently we were working on a project for Siemens Design Challenge where we were designing an off-grid refrigeration or air conditioning system for our farmers so that so we can reduce the food loss drastically. So we went through a new method while researching through this for this project. We went through a new method called desiccant wheeled refrigeration system. So can you please elaborate on this? We were not able to access any journals regarding this desiccant wheel method.
And
So
first of all, I
why
would like
is
to
that
answer
a
you.
failure?
No, no, it is not a failure. It is very popular. It is, I'll tell you, only thing is, it is called slightly differently. That is all it is. See, what happens, you have the supplier and returner, right? We have seen
Yes,
in
sir.
let me share that. Let me share that so that I can explain it a little better.
Yes, sir.
Are you able to see this?
Yeah.
Yes, sir.
See, if you look at the returner,
Yes, sir.
one second. It's taking a little while. Let me just, yeah.
Oh yeah, you're good now.
See, here at this particular point, on the left-hand side, I don't know how to take it. Are you able to see my mouse?
Yes, sir. Yes, sir.
Yeah,
Yes,
here,
sir.
here is outside air. Here is the exhaust air, right?
Yes, sir.
And this is the return air fan. Now, again, this outside air is coming and going to the supply fan. This is your supply fan.
Yes. Yes, sir.
Now, the desiccant wheel is
Yes, sir.
placed somewhere here in this. Meaning, the exhaust air, as we know, is at 72 degree F. We have seen that inside temperature.
Yes, sir. Yes, sir.
That is at a very low temperature. So unnecessarily we are leaving away the heat. And this outside air is at about at 100 degree F is it coming in. So when we use a desiccant wheel, it is kind of a heat exchanger. It's a kind of a flywheel. It takes the heat from here.
Yes, sir.
Okay, it takes the heat
Yes, sir.
from here, and it takes away the heat from the outside air and adds to the exhaust air. That thereby the outside air will come down. The temperature of the outside air will come down by at least 10 degrees F. So it is a heat exchanger. We are using this to reduce the temperature of the outside air. So it is used here. In majority of the applications, it is used where you are throwing away a lot of exhaust air and you are bringing in a lot of fresh air. We are using it for smaller applications. It doesn't make any commercial sense, so we don't use it.
But we can't reduce it below 20 degrees, sir. Below 20
No, we
or 18
can't.
degrees Celsius.
You can't.
Okay, sir. Okay, sir.
Thank you.
It has its own limit. If you have to increase, then you have to increase the size of the the resistant rotor size will be very, very big, and it is not worth it. See, again, finally, anything will boil down to what is the commercial cost.
Yes, sir.
And the size of the system, the cost benefit analysis, right? So
Okay,
that is
sir.
why it is not. It is used in many applications like hospitals where you have large amount of air is coming from fresh air is coming inside. Large amount of exhaust air is exhausted in industrial applications also where there are number of air changes is more required more. Then you definitely use these desiccant wheel.
Okay, sir. Okay, sir. Okay, sir. Thank you, sir.
Thank you.
Thank you, Venki. Anybody else? Any other questions from anybody else?
Okay, then KK, I think looks like we have no questions now. We will wind up. Thank you very much once again for all the participants and also to Ganesh sir. Thank you very
Yes,
much
sir.
for your time. Really pleasure talking to you, meeting you here.
Thank you.
Thank you, Mr. Ganesh. And it'll be a pleasure to meet you once all this is over. I definitely want to come over to the college and meet up with you. Now, after seeing you on video, I vaguely remember I met you before, but maybe, might be in different circumstances.
Right. Bye. Take care.
Yeah.
Thank you.
Thank you very much, everyone. Just like I always do, if you still have any questions, feel free to send it to my email address. You guys have my email address. And I'd urge all of you to send for the participation certificates. I want to ensure that you send the right name that you want on the certificate with an email to me. I'll make sure you get your certificates on time. Thank you very much, everyone. Thank you very much, sir. I look forward to meeting you soon, sir.